This video presents our work on sampling strategies for neural network-based collaborative filtering. Recommendation in content-rich environment has various applications, such as news article recommendation. Can we predict which text article a user is interested based on its past interaction data? We consider a neural network-based collaborative filtering framework. Users and items are associated with feature vectors. With differentiable embedding functions, user and item features are turned into embedding vectors. The interaction between a pair of user and item is computed by their inner product. This process is summarized by the formula: computation cost increases when we use sophisticated neural networks. We observe that computation cost is dominated by the neural network computation, forward and backward, for items. We identify a connection between computation cost and user-item interaction graph. Here positive interactions between user and text are colored red, and negative interactions are colored black. The loss functions are defined over interactions or links between users and items. But the major computation burdens are on nodes, especially item nodes with content features, so different mini-batch sampling can result in different computations. Existing approaches are based on IID or negative sampling where the node computation cost cannot be amortized. We propose 3 mini-batch sampling approaches to improve the training efficiency. The first one is stratified sampling by items. The idea is to group loss function terms by shared heavy lifting nodes, items for example. Instead of sampling links in IID manner, we first sample an item. Then sample some of its positive interactions and some negative interactions. This is repeated until the whole mini-batch is sampled. The second proposed approach is negative sharing. The main idea is to add additional links in a mini-batch with few computation costs. We simply sample positive links in IID manner, and then generate negative links by connecting non-interactions in the mini-batch. Although they both speed up the computation, the two sampling strategies have limitations as well. For the stratified sampling, it cannot work well with ranking-based loss functions. For negative sharing, it samples too much negative interactions, diminishing return is expected. So we propose to combine both strategies to overcome their shortcomings, while keeping their advantages. The idea is to draw positive links using stratified sampling, generate negative links using negative sharing. Specifically, we first sample an item, and some of its positive interactions. Repeat when positive links are sampled. Then, negative interactions are generated by connecting the non-interactions between users and items in the mini-batch. The proposed algorithms are both theoretically and empirically verified. In our experiments, we observe a significant speedup with the proposed method, up to nearly 30 times faster than existing approaches. With faster training, do we sacrifice performance? The answer is no. We see the strategies with negative sharing can even improve the performance. This is reasonable since more negative links are utilized by these methods. We encourage the viewers to check out our paper for details. Thank you for watching.